This program will introduce you to the for loop. And in this program, we're going to do some simple calculations, and we're just going to print out, really it's not really any calculations, we're just going to print out some numbers. So this illustrates the syntax of the for loop. We have some variables already declared: integer counter set to 0, float x set to 0, and we have a float for degrees F and degrees C that are also set to 0. So we'll do a calculation for converting degrees Celsius to Fahrenheit at the end. Okay, in the first case, we just want to print out the numbers from 1 to 10. Okay, so that will go right here. All right, now let's look at the syntax of the for loop. The for loop starts, as you might guess, with the word for. And then inside parentheses, we have some information. Okay, so we'll close that. And then you have a body of code that's delineated by the curly braces, just as we have seen with the while loop. However, inside the parentheses for the for loop, we can put a great deal of information. In fact, we can put 3 items inside this set of parentheses. So let's look at the first item. The first item is going to be the initialization. So your counter that we have initialized outside of the while loop already, you can do that here as part of the for loop. So in this case, I'm going to use counter as my loop control variable. So I will set counter equal to 0 and then put a semicolon. All right, so this first thing on the left inside the parentheses, this will be the initialization of your counter, and now that is part of the for loop itself. It is not a line of code that appears before the loop. Now the middle thing that we see in the parentheses following the semicolon is the same test that you've seen in the while loop and the do while loop. In this case, we want to print the numbers from 1 to 10. So when counter reaches 10, then we want to exit the loop. So we put the test condition here. Counter less than or equal to 10. And then we put a semicolon there. Now the third thing is going to be the increment. So on the far right inside parentheses, you want to specify how you want to change your loop control variable, in this case counter. And we are going to just add 1 to counter, and you can do that in any of the 3 ways that we have seen. But the most common way to add a single value to an integer variable is to use the increment operator ++. Okay, so that will add 1 to the variable counter once we get to the end of the loop. Now I realized I have a mistake because I want to print the numbers from 1 to 10. So I need to initialize my counter to begin with 1 instead of with 0. All right, so remember this. With your for loop, you can specify all 3 things within the parentheses following the word for. You specify the initialization for your counter. Okay, the second thing is going to be the test condition, so that when this becomes false, you'll end the loop. And on the far right, you have an increment to add or take away or do some calculation that will alter the value for your counter. You specify all 3 of these inside the parentheses. That simplifies the body of the loop. In this case, since we're only printing out the values, we can use a printf double quote, and all I want to print out is counter, which is an integer type. So I'm just going to use %3d, and I want these to be on the same line. So I'll use a %3d double quote, comma, and then just print out the variable counter, right paren, semicolon. Okay, so that's all I need in the body of the loop. I don't need to increment the counter because that's taken care of up here. Now it may appear that this incrementation will take place at the beginning, but it does not. Even though you've told the incrementation to be 1 at the top of the loop, the incrementation does not actually happen until you reach the bottom of the loop, just as it would if you were hard coding it or coding it for the while loop or the do while. Alright, now we are going to skip a couple of lines after this. And so that we can see what happens, let's include a system pause here so we don't go any further with our program. And that will allow our output to stop at this point. And then as we add the other cases, we'll also have a pause, and we'll just step through those. Alright, so let's look for case 1. Okay, so let's build our. Let's run the program. And here we have the output for case number 1. Okay, here are the numbers from 1 to 10, and you can see that we output the numbers 1 through 10 on a single line. So this for loop implements that. Of course, this is not a very useful application. This is just to show you the syntax of the for loop, but you can tell that we could put calculations inside the loop that would use the numbers 1 through 10 in any way that we choose. All right, now let's move on. Let's stop this and let's move down to the second case. And I'll move a little faster now. And in fact, what I will do is just copy the for loop from the first case and make some modifications for these other cases. So I'm just going to copy case number 1, and yes, I'm going to overwrite that printf with the 2 \n because I've included it with what I copied, and I'll paste it in. Okay, so now we still have the skip 2 lines and system pause in there. Now, case 2. Here are the numbers from 10 to 100 by tens. All right, so our counter this time, we want to begin with the value 10, and we want to stop when we get to 100. So the way we would write the for loop in this case will be as follows. Okay, we want to initialize our counter with 10. Then for the test, as long as our counter is less than or equal to 100, we'll stay in the loop. In order to do the increment, I have to add 10. The plus plus operator only adds 1, so I cannot use it. Okay, so let's replace it. And 2 things we can do. We can do counter is equal to counter plus 10, which is a common way to do that. Or we can take advantage of our assignment operator and shorten this by using plus equals 10, which is exactly the same thing. So to increment then, we're going to use counter plus equals 10, which will add 10 to the value of counter. Okay, we're printing out the values 10 to 100, so I can just go ahead and reuse this output, even though in the last case the 100 is going to be next to the 90, but we can see what's happening there. All right, so let's build this, run it, and see what the output's going to be. We're going to see these cases build up as we go along. And here is the output from the first case. We had the numbers 1 through 10, and there's a system pause, so that's why you see the statement there. Now, to make it go further, we just hit any key, so hit the space key, and we have case number 2. Okay, so this case number 2, right below the window, here's the for loop that outputs the values 10 to 100 by tens. And you can see the values 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So that's an example of the for loop that will count by tens. Okay, let's stop this. And let's move on to case number 3. Okay, case number 3, we're going to count down from 10 to 1. So we're going to count down this time. Once again, I'm going to go copy what I did for case number 2. And then we can just copy that, paste it, and make some edits to get what we need. Okay, I did a Control-C to copy. And I will paste it in here. And align items. I've got an extra printf with the \ns, which I'll delete. Okay, so how do we change for case number 3? Okay, we want to begin with 10, and we want to continue until we reach 1. So we can initialize the counter to 10. That's fine. That works okay. But this test is now going to be incorrect. Since we're going towards 0, we want to exit the loop when we reach the value 1. So one way we could change this is to say counter is greater than or equal to 1. Okay, alternately, we could say counter greater than 0, and it would still work. In order to take the counter from 10 down to 1, however, we need to subtract. We're subtracting 1, so we can use the decrement operator -- or --, and that subtracts 1 each time. So this time we will begin at 10, and we'll go to 1, and we'll subtract 1 each time. All right, so then we should get the output 10 down to 1. I'm going to build a program and run it. And once again, we'll step through all 3 cases. So here's case number 1, the numbers 1 through 10. I'll hit the space key. And here's case number 2, the numbers 10 up to 100. And now I'll hit the space key one more time, and we'll see the numbers counting down from 10 to 1. So case 3, here are the numbers from 10 down to 1, and you can see them printed out, and it works just fine. Okay, so here's the example of the for loop where we're counting down with an initial value of 10 down to 1, subtracting 1 each time. Now let's move on to case number 4. I'll do my regular routine. I'll copy the for loop from the previous example. Now paste it in for case number 4. And I'll take away the extra printf to skip 2 lines since I already have that. Now we want to print out the numbers from 100 all the way down to 0 by tens. Alright, well let's see. That means our initial value is going to be 100. So we'll initialize the counter to 100. And as long as the counter is greater than or equal to 0 this time, I want to print out the value 0. So as long as counter is as long as the counter is greater than or equal to 0, we want to stay inside the loop. But I can't use the dash dash to just subtract 1. I have to subtract 10 this time, so we have to go back to the assignment operator. And we'll have counter minus equals 10. So that assignment operator will subtract 10 each time. That's exactly the same as putting counter equals counter minus 10. I don't need to change the print statement because it still prints out the value for counter. So let's build this program and run it and see what this output will be. You have 4 cases to go through. Case number 1 you've seen. Here's case number 2. Here's case number 3. So now let's look at case number 4. Case number 4, here are the numbers from 100 down to 0 by 10. And you can tell that that is what we get. 100, 90, 80, and so on, all the way down to 0. And as I reposition the window, then you can see case 4 and the for loop that made that output occur. Should be pretty straightforward. Alright, moving on, let's go to case number 5, which will be a little bit different. So I'm going to copy the for loop from case 4. I'll print it in here. I'll paste it in there. Alright, and then I redundantly have the printf for 2 lines to skip, so I'll take that out. Case number 5. Here are the powers of 2 that are less than 100. Alrighty, so what do I mean by that? I want to print out the value of 2, then 2 squared, then 2 cubed, and so on, until I get all the powers that yield a value that it's less than 100. The initial value for the counter, we're going to start with 2. So we want to print out the value 2, so that's what we want. And we want to continue as long as the counter is less than or equal to 100. So we will change that back to less than or equal to 100 as the terminating condition. But this time, instead of adding or subtracting, we're going to multiply. So each time we multiply counter by 2, then we're adding a power of 2. Okay, so counter asterisk equals 2 is the same thing as saying counter equals counter times 2. So think about this. Think about how this will go. The first time through, counter is equal to 2, we print out 2. The next time through, counter is equal to counter times 2, so we get 4. The next time through, the value of counter times 2 gives us 8, and then we get 16 and 32, and finally 64. It will stop there because the next power of 2 would be 128, and that's greater than 100. Okay, so to see the output, then we'll build this case and run it. We're building up quite a few cases now. We have 5 of them. So there's case 1, case 2, case 3, case 4, and now let's look at case 5, which is the powers of 2. So case 5, here are the powers of 2 that are less than 100, so you do see we get 2, 4, 8, 16, 32, and 64. And I'll uncover the for loop that generated those values so you can see that clearly. Counter equals 2, counter less than or equal to 100, and the increment is counter equals counter times 2. We have a couple more cases to do, maybe 3, I guess, or 4. All right. In case number 6, we're going to repeatedly divide a value. All right, so let's go ahead and copy the for loop from case 5, and we'll paste it in here for case 6. And in this case, we want the quotients. Okay, so we're going to start with 100, and we're going to divide by 2 until we reach the value of 1. This is going to be an integer divide because counter is an integer, so we will not have any fractional parts as a result of the division. Initial conditions. Okay, the counter is going to begin with 100, so we initialize counter to 100. I like to have a space there. And as long as our counter is greater than or equal to 1, I want to stop when we reach 1, then we will continue in the loop. And the way that we update or increment counter is to say counter is equal to counter divided by 2, if you want to write it out like that. Or you could do the counter slash equals 2, which is exactly the same thing using the assignment operator. But I'll leave this one the way I've written it here. We don't have to change the print statement because, again, we're printing out counter. So let's build this and see what we get for case number 6. The output window is getting pretty crowded. Case number 1, case number 2, 3, 4, 5, and our latest one, well, let's scroll down a bit for that one. This will be 100 repeatedly divided by 2. So here are the quotients from repeatedly dividing 100 by 2, and you can see the answers. Okay, 100 is what we start with. Divided by 2, we get 50. Divide that by 2, we get 25. Divide that by 2, we get 12.5, but it's an integer divide, so we don't keep the fractional part. Then 12 divided by 2 is 6. 6 divided by 2 is 3. And finally, 3 divided by 2 is 1, since it's an integer divide, and that's where we stop. So here's an illustration of the for loop that where we're using to generate a series of numbers where we're dividing 100 by 2 and the result by 2 and so on. Now let's move on to case number 7. By now you know how we're doing this. We'll copy the for loop from 6, paste it into the space we have for 7. And this time we're going to just show that we can use these loops with real numbers instead of just integers. Okay, so we're going to print out the values 0 to 2.0 in increments of 0.25. All right, so this time we need to change our variable. Counter was a type integer, so we cannot use that. But I did declare a variable called x, which is a floating point number or a real number, and we will use that instead. So this time we have some major changes to make. We have the variable x that we're going to use, and we want x to be initialized with 0.0. I like to use a period whenever I'm initializing or using a hard-coded number with a type float, so that really tells me this is a floating point or a type float number. Okay, so in x initialized to 0, as long as x is less than or equal to 2.0, so x less than or equal to 2.0 is the terminating condition. And to update x, I want to add 0.25 each time. So we could do x plus equals 0.25. So that is the increment. X starts with 0. It continues until we reach 2.0 in increments of 0.25. I also have to change the print statement because now I'm printing out a real number. So let's use a %5.2f, and we will print out the value for x as we go through the loop. And I'll erase this extra printf once again. Now let's build this and look at the output we get for part number 7. In this case, we're going to see some real numbers. So let's go through the cases 2, 3, 4, 5, 6, and now we're down to case number 7. So I'll hit enter again. So here's case 7. Here are some real numbers from 0 to 2 by by 0.25, and you can see the outputs. 0.00, 0.25, 0.50, and we're adding 0.25 each time until we finally reach 2.0. So this just illustrates the use of the for loop with real numbers instead of integers. Okay, so there's again the for loop to show you how to do that. Now the next case, case 8, here's some real numbers from 10 to negative 10 by an increment of 2.5. Let's copy the for loop and let's paste it here and make some modifications. Erase that printf statement again. Alright, so this time we're going to start at 10 and we're going to keep going down to negative 10 by 2.5. So we'll initialize x to 10.0 and we want to continue as long as x is greater than or equal to negative 10. Okay, so here we're seeing a negative number, 10.0. So we're starting at a positive 10 and we're going to continue until we get to a negative 10. And since we're counting down, then we need to subtract a value. So I'm going to use the minus equals assignment operator, and we're going in increments of 2.5, 2.50. Right? So that's how you write this statement. X initialized to 10. We continue until we reach negative 10, and we're going to subtract 2.5 each time. Okay, so now that's all we need for this one. Let's build it and run it and look at the output for case number 8. We have the output. Let's step through the cases. 2, 3, 4, 5. I'll scroll up. 6, 7, and here's the one we're looking for, number 8. Case 8. Here's some real numbers from 10 to negative 10. So you can see the outputs. 10, 7.5, 5, 2.5, 0. And then the negative sign kind of adjoins the numbers. So I might have needed a bit more space there. But you see minus 2.5, minus 5, minus 7.5, and finally negative 10 on the far right. So that illustrates how to count from some positive value down to a negative value. We have one more case to do. And this one is a little bit more useful. It's going to be a temperature conversion. All right. So in this case, we are going to print out a Celsius to Fahrenheit temperature conversion table. Okay. So we need to have some values for this. So this, instead of just counting, then we're going to produce a table. So let's look at how we can do that. Now notice I have a printf statement that'll print the word Celsius, a couple of tabs, and then Fahrenheit. So those are going to be column headers. That'll be at the top of our table. So we have the for loop, and I'm going to use degrees. Let's see, what do I want to compute? I want to compute degrees Fahrenheit given degrees Celsius. So let's use degrees underscore C as our loop control variable, and let's set that equal to 0.0. It is a float with a semicolon. And how far do we want to go with this? Okay, let's say 100 degrees Celsius. Okay, so degrees underscore C is less than or equal to 100.0, semicolon. And let's add an increment to our temperature in degrees Celsius of 10 each time. So degrees underscore C plus equals 10.0. Okay, then in the body of our loop, we want to compute degrees F given degrees C. So degrees F is degrees Fahrenheit, and that's equal to 9.0 divided by 5.0 times degrees Celsius plus 32. Okay, then we need to print both of those numbers out to our table. So we'll do a printf, and they're real numbers. So let's do a percent. Let's see, 1, 2, 3, 4, 5. Let's do a 6.2f, and I'll put a tab and a tab, and we might need to adjust that. Okay, then let's do another percent 6.2f for the value for Fahrenheit. Then we'll \n, double quote, comma, degrees underscore C, comma, degrees underscore F, right paren, semicolon. And that will be the end of the loop. So this one will be a little bit more involved. We have an initial temperature of C. When C reaches 100, we will stop, and we're going to add 10 each time. Inside the loop, we're going to compute the equivalent in degrees Fahrenheit, and we do need to divide by real numbers here so that we don't have a fractional, an integer divide, which would end up being 1. So make sure you get the 9.0 divided by 5.0 so that it knows to do a real divide. Okay, let's build this and see what our temperature table looks like. So this is our last case. Here's our output window. And let's quickly step down to our last case, case number 9, 2, 3, 4, 5, 6, 7, 8, and now we can see the temperature table. All right, so here, oops, I've made a mistake in the syntax here, so I printed out the format instead of the value for Celsius. So let's stop and fix that. You can see that what I did here was to forget to put the %, so I got a syntax error. So it should be %6.2f, and over here 6%6.2f. Okay, so now let's try that again. We run the program, and let's get down to case number 9. Okay, now we're ready for case number 9, the last one. And now our table looks better. So you can see we begin with a temperature of 0 degrees Celsius. We stop at 100. And on the right-hand column, we have the equivalent temperature in Fahrenheit. So in this case, we have used a for loop to do something useful, and that is generate a conversion table from Celsius to Fahrenheit. Well, that's a lot. Okay, there are 9 examples of how you can use the for statement in various types of counting, and finally to calculate a temperature conversion table. All right, so that's all for this video, and I will conclude now.